Can Keras be used for sequence-to-sequence models in machine learning? Have you ever wondered how machines can translate languages or summarize texts? The answer often lies in sequence-to-sequence models. Today, we will explore whether Keras can be used for these fascinating models in machine learning. Yes, Keras can indeed be used to build sequence-to-sequence models. These models are designed to transform sequences from one domain into sequences in another. They are widely used for tasks such as machine translation, text summarization, and conversational artificial intelligence. Keras provides a flexible application programming interface that makes it easier to create encoder-decoder architectures. In this setup, the encoder processes the input sequence and encodes it into a fixed-size context vector. This vector captures the essential information from the input. The decoder then generates the output sequence step by step, often using recurrent layers like long short-term memory or gated recurrent units. One of the key features of Keras is its ability to return internal states from recurrent layers. This is done using the return state parameter. These states are passed from the encoder to initialize the decoder, ensuring a smooth transition from input to output. Another important feature is the control over the output of recurrent layers. You can choose whether they return the full sequence of outputs or just the last output using the return sequences parameter. This is crucial for decoding the output correctly. Keras also supports defining custom inference loops. This allows you to generate output sequences token by token during prediction, which is particularly useful for tasks like language translation. In practical implementations, the encoder encodes the input sequence into state vectors. The decoder starts with a special start-of sequence token and generates the output iteratively. This continues until an end-of-sequence token is produced or a maximum length is reached. Keras has numerous tutorials and guides that demonstrate these concepts. For example, models trained to translate English to French can produce coherent sentences. From the perspective of artificial intelligence and machine learning, sequence-to-sequence models in Keras show how deep learning can handle variable-length input and output sequences. This capability enables applications such as chatbots and automated summarization. However, as we embrace these technologies, we must also consider the ethical implications. Ensuring fairness and avoiding bias in generated content is essential. This aligns with the principles of responsible artificial intelligence. In summary, Keras is a user-friendly yet powerful framework for building, training, and deploying sequence-to-sequence models. This makes it accessible for developers and researchers working on various applications involving sequential data.